Hello, my name is Bill Krantz. I'm a professor emeritus at the University of Colorado in the United States. My collaborator is Professor Tse Howard Chong at Nanyang Technology University. Our tech offer is a new membrane module design called Centrifugal Reverse Osmosis. This technology addresses the global water crisis that is suffered by 40% of the people in this world. Only 0.008% of the water in the world is available as fresh water to meet the needs of our 7.7 billion people. This water crisis is exacerbated by water contamination, climate change, and rapid population growth. The only way to increase our freshwater resources is by seawater desalination, for which membrane reverse osmosis is the most economic technology. However, reverse osmosis is expensive, owing to the high pressure pumping costs that can be significantly reduced by our tech offer of centrifugal reverse osmosis. Conventional reverse osmosis operates by pumping the entire membrane module up to the maximum pressure required for the desired water recovery. However, the lowest pumping energy cost corresponds to having the local pressure in the membrane module only slightly above that required to cause permeation. This can be done by rotating the membrane module to create a centrifugal pressure that increases with distance from the axis of rotation. This figure shows an oblique view of a centrifugal reverse osmosis module. The feed enters through a centrally located hollow tube and flows radially outward. Water permeation occurs through the membranes owing to the progressive increase in the feed side pressure owing to the rotation. For example, the pressure required for a 50% water recovery from a typical seawater feed can be achieved with a module having a radius of only 0.72 meters, rotating at 1,000 RPM. This slide shows a semi-transparent view of the centrifugal reverse osmosis module with a parallel stack of M8 membranes and associated feed and permeate channels. The freshwater permeate flows radially outward and is collected and withdrawn from a non-rotating cylindrical container. The concentrated brine on the high pressure side of the membranes flows radially outward and is directed downward through a series of nozzles to impinge upon an array of stationary vanes that enables harvesting its pressure energy to rotate the module. Closed-circuit reverse osmosis is a competitive technology patented in 2009 and commercialized by Desalination and purchased by DuPont in 2019. Closed-circuit reverse osmosis continuously recirculates the seawater feed while gradually increasing the pressure in the entire module to cause permeation at a pressure only slightly above the required minimum. Seawater feed is continuously added to the recirculating feed on the high pressure side of the membranes. The pressure is increased until the maximum pressure is reached for the desired water recovery. However, closed-circuit reverse osmosis is a batch process that incurs significant energy losses owing to recirculating the feed and to mixing fresh seawater with the concentrated recirculating feed. The advantages offered by centrifugal reverse osmosis are summarized in this slide. It is a continuous desalination process that operates at the minimum required pumping energy. For example, for a typical seawater feed, it can reduce the specific energy consumption relative to conventional reverse osmosis by 45% for a 67% water recovery. It is advantageous relative to the closed-circuit reverse osmosis process because it is a continuous process that does not incur any energy losses owing to recirculation and mixing streams with different concentration. Nanyang Technology University has been awarded a PCT patent for this technology. We now are seeking an industrial partner to advance this technology to the marketplace. Thank you for your attention.